Welcome back to Designing AI-driven Personalized Learning Environments course. In this video, we'll talk about dynamic Bayesian network. In last video, we saw what is Bayesian network, but single Bayesian network, it looks at one particular moment. It is not talking about how it changes over the period of time. So, but learning, when you start to introduce the Bayesian network in a learning, it's not a single instance. It is, you learn from one question to next question, you come from today to tomorrow, year after year. This learning is continuous progress. So, in order to capture this continuous process, we'll move on to the dynamic network. What is dynamic network? Dynamic network is nothing but a series of static Bayesian networks on a different time period. For example, for time period 1, this is the graph. In time 2, the graph might change. In time period 3, the other graph changes. Now, it's kind of complete in the sense it includes the hidden nodes and known nodes, also the dimension of time also coming into picture. But if I have 10 questions or 20 questions, I am writing a lot of dynamic Bayesian network, then the state 10th, the value of a dynamic network depends on all the states 9, 8, 6. It will be too much computationally costly. To avoid that, we use the Margot assumption, which means the future depends only on the present states, that is future, that is t plus 1. Present is this is a present state. The future, that is t plus 1, will depend only on the current state. So, that is the Margot property, and we will use only that property in this. Why we are talking about this? This Margot property of the future state depends on the present state, or the present state depends only on the future state, previous state. It will be useful to compute the learner's mastery skill over the questions. How it is valid? The current state depends only on the previous states, not on the previous to previous states. When we compute this kind of problem, the previous state, that is state t, would include the previous state. So, we are compounding all the values for the period. So, in a dynamic Bayesian networks also, it's a time at the different times, it's only the two states. State 1, state current state depends on future state, or future state depends on current state. That's all. Thank you.